Hello, guys. Here on more just tutorial for you, presenting for you. Um, how I said before, just making not just only on tutorial, but a workshop, an unofficial workshop, because I have a sequence here of example, and well, I used to do it, just talking about our official definition. This SreamingFlow4J, it's 100% of open source, and well, it's real-time data processing using pipelines with Apache Kafka, Redis, RabbitMQ, and this is a wrapper with SPRCP engine for SPRCP engine, complex event processing engine, and well, more than this, use all the patterns of event-driven architecture, and more than this, it's a service mesh for microservice. Uh, People used to ask to me about what is recommended. I used to say that's too good for make analytics. I have, if you are just following the this non-official workshop in some tutorials before I present some example, real world example. Our example of today's processing of massive data and big data. Well, I will not, of course, I will make a mock-up as something make just to simulate uh, all the 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 processing and big data, but it's so hard to simulate that. So I just show for you some example, real-time example, um, real world, real-time processing example, using some charge of big data. I explain it, but uh, it's hard to simulate big data processing because uh, it's it demands a lot of memory and resource and anyway, and well, I just make something simulated here just for show to you that this massive data could be processed in real time using parallel in parallel processing and everything made in memory. Uh, when I start to show for you, you understand better. Uh, Another example, the first one was about the mockup of uh, mockup of IoT that I showed you. I talked about our architecture. This is based in event-driven architecture. We have some layer here of administration that receive our queries, as receive our queries, and in these queries are our management of this layer of the application is SreamingFlow4J, and how you can operate it's this is layer. Uh, we're gonna create some producer trying to simulate something in real world example just to put the real time processing and consumer just to receive this information. Uh, in the middle of this, of course, we have SreamingFlow4J with our wrapper for Esper engine and of course operating and in the pipelines uh, in the middleware pipelines using in this case in the next example I just show it for you before example with RapidMQ, but this example about big data, I use Kafka. Uh, how I said before, our REST API is something that is very useful for. We just create the management of the application just to edit and delete and create new rules and new new event and new rules, how you can see. And it's already explained it in some tutorials before. And well, if you have some doubts or something, you can just send to me some email. Anyway, but if you follow this non-official workshop, you will understand and you have no problems and make all the processing. This is our first practical example that I show it to you on IoT mockups. If you go for the first tutorial of this non-official workshop, you see it is implemented in practice. After that, I just show it the practical example analytics, and right now I show to you our practical example of big data clutter. Of course, just simulating something about big data. But imagine you are in a real world condition that you have a system that collect the speed, the velocity of the cars in a road traffic, and for this specific for this processing, I will use some AI module. We are talking about subsea mesh and microservices and anyway. In the sense of distributed systems, we just create uh, the focus actually is not this module. This is a artificial intelligence that they created to make analysis of this traffic in the road and analyze the velocity and based on the real real time conditions, real world conditions, how you can just show for you. It can just forecast uh, about the concept drift and just change our situation. For example, you have bring me all the vehicles in the traffic road where your speed is over 130 kilometers hour. In case an occurrence of concept drift up to date, automatically the predefined condition proportionally to the traffic risk in real time. Well, we just gonna create some rule like this. Just select the ID from vehicle. Vehicle is our our event, the, and just to capture the speed over 130, but the analysis made by our our artificial intelligence. I'm just using here just some old school machine learning processing. I'm not too much specialized at that, and so it's something just to make uh, to show in practice this concept drift and imagine in a situation that uh, that are starting a rainfall and the velocity of this car just will decrease. But even with this decreasing, you just can can capture the proportion of this velocity that was predefined with the speed over 130 kilometers hour. And more than this, this is will made automatically because our our artificial intelligence here. Of course, you can use. You feel free for use yourself implementation. I'm just showing that you can just create some implementation, some real-time things, and you just adapt the rules or your new conditions. And this is the 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 best thing in SreamingFlow4J because you can just make it on the fly. Just use some artificial intelligent agent. You can just use the modern implementations of about uh, about uh, about artificial intelligence, OpenAI, and other ones. But uh, this is very important. Is the capacity or the capability that SreamingFlow4J offer for you to make this change on the fly. And if there is there is some condition with concept drift, for example, it will offer the opportunity of you make the updates automatically. Uh, just stop here because I think that we're gonna make a hit. Is just the practical example with code and anyway. And so uh, the first thing that you can see here is just an analysis of the charge of this data. Uh, I'm using I'm using Jupyter Python here just to make this analysis and how we just we're gonna create this. No, because we simulating the real time condition. This is what will happens. This is the monitoring, normal, regular monitoring here, and it starts a rainfall here, strong rainfall, and the speed of velocity of the cars will just you just decrease. After that, it turn to normal condition, and again the rain start again, and the decrease of car will happen. And all the analysis here uh, is made by our artificial intelligence and monitoring this when this concept drift happens. Um, it just make an update called the updating and StreamingFlow4J for the StreamingFlow4J came at this point and just capture this information. Uh, I think that the best thing is so I would say they create some consumer here, and of course I show it for you in uh, some tutorials before. It's so easy way of to make the starting using Docker and building and and making all the deploy here and just right now it's just running in the Docker. You gonna just use only the StreamingFlow4J here and just a middleware just to receive the layer of uh, our uh, just start here again. Just the layer of administration. How we can, you're gonna see, I create this module just to a consumer. I just started the consumer. How I used to say, well, if you have any doubt about it, uh, and this is our producer now, just started, and you simulate all this discharge of data. You make it in real time in a pipeline of of Kafka, and uh, this is our this is our application of artificial intelligence here. Uh, Here, just now our agent, you analyze that processing, and based on based on uh, okay, based on our conditions of concept drift, we'll just analyze that and make all the all the updates in roles. There is something very important here. Is this algorithm here? It's so singular. It's not sharpened for this situation. It's something golden. This is old school of artificial intelligence. How I said before, you just can use something about OpenAI, just another new implementations of LLMs and whatever. Um, the focus is not here. This is not the focus. It's not part of SreamingFlow4J. The accuracy maybe is not too good, but how the focus is not this processing artificial intelligence processing. Uh, we're gonna just realize that you have the opportunity of in conditions of concept drift, uh, how I talked about before, when we are just capturing the velocity of car in a traffic road, and you start a rainfall, and with this rainfall, all the all the predefinitions of that was made in the rules need to to have a change. And well, you just gonna realize that. Yeah, we started our agent here making analysis process. Well, okay, just send the information out because oh, before of this, we can just yeah. I'm sorry. We just need to create the event now, because if you do not create the event, yeah, we're gonna use our API here, create the event here, and they will have an ID and a speed to calculate that. Because if you send all the information and you do not create this management, it will not understand what happens in that moment. SreamingFlow4J, you should make the management of events. Yeah, we're gonna create here. Okay, if you just check it out in SreamingFlow4J, it's already created that just to see the logs here. Yeah, it created that event, add event class vehicle, but it knows the event vehicles, but there is no roles. So the next step is to create a role. Uh, I made some tests before here. It's pre-programmed here. Create uh, that rule is here. No? Just select the speed from vehicle where the speed is over 130 kilometers. And okay, just to send that, just to check it out again. It's here, no? It create the query, and now they we understand the concept and uh, how I create a processing here. Just uh, okay, I just make some adapting because the the registering of the logs here just it should to be made just to because this is very important based in this idea is automatically recover the rule here and make the change. So right now we're gonna start the processing. I put a lot of thread sleep here just okay and the producer I create some delays here because uh, we just are simulating this processing and this how is so fast. Even I just put um, millions of of information here. It just create a huge processing. And anyway, it's so hard. So put a delay here just for side by side in this processing. We just go processing and seeing the mm, everything happening because uh, in a normal condition of big data, it should be processed in some small seconds. So let's go there. It's processing the information. You comes here in the analytics. Uh, it start to make the analysis. No, or you see the speed here over 130. Uh, it's not made the predefinition analysis, but when the processing arrive here, I think that how I said before, it's not too much sharper. It's not too much sharp, and the accuracy is not good. But it will make this change and make the updating and the role. This concept review happens right now. Sorry, right here, and when happening, you just realize that change. processed more than uh, 500 500 uh, data, but when arrives something between 1,500 and 2,000 here is the point of concept iteration. So we're gonna analyze here. It's a red close off 1,000 and keeps the behavior predefined over 130 here. Yes, it's processing. You can see here just all the processing of our uh, our artificial intelligence. I just made this analysis, this algorithm. I developed it in 2018, and uh, in my thesis of PhD, but my PhD was declined, and well, I'm just using it because actually the SreamingFlow4J arrived like a proof of concept of my PhD, and in my PhD, this algorithm is it's it's something that I create for myself, and how I say it's not accurate, and the accuracy is not too good, but and after that, just rest the streaming flow for J, and well, streaming flow for J is today my side hustle, and I love it. Yeah, you just right here, just you can see the concepts drift happening here. They happened again. It just already changed for two times in this exactly moment. Two times the the rules and the concept drift happening here. Oh, so nice. And you're gonna see that you change only only on time again, just to simulate that the rainfall will start again. The rain start again. It will return to change uh, the value of the the logistics of the rule, and just creating uh, another proportion for this logic. Yeah, just again, just change for this. If you realize that the the when you are was the behavior, the normal behavior, no, it was the speed over 130, but in a moment of rainfall, strong rainfall, it just captures something over maybe 40 or whatever, and return to something about 150, and return again just to this point here over something 80 or 75 kilometers. That's so nice, so nice. How I say the analysis of the artificial intelligence. Is artificial intelligence was made to concept to forecast the concept drift, but is not is not sharp. It's not accurate. Yeah, I think that it processed everything here, and everything happened. So I think that's it because it's just finalized here. Close of 4,000 here, but I just finalize it here because um, I just showed to you that the behavior keep the same. Well, just change with some real time conditions, real world conditions happening. And so I think that's it. And oh, more than this processing, if you understood everything that was made here, I'm so happy. If not, how I used to say, you can just send a message to me. If you goes here, uh, SreamingFlow4J.io, this is our official web page. This is uh, this is my contact here. You have my LinkedIn here. You have my official my official email here, and will be a pleasure to help you. So this is our official, the link of our official repository, and uh, the YouTube tutorials. This this right now will be this and this link here. More than this, just thank you very much. Thank you. Bye bye.